Hi, this is Miss Conley and Miss Andrews, and we're going to go over a couple of problems involving exponents. So we have this first problem here, and you notice two sets of brackets, and there's no operation written in between the brackets, so that means we are multiplying. So this is one big multiplication problem. The first thing we should do is look for our coefficients. In that first set of brackets, we have a negative x to the fourth, so that means that's a negative 1 as our coefficient. So let's write that in so we don't forget about that. And we also have a y there, which is y to the first power, so let's write in that 1 as well. Okay, so now we're ready to multiply. So our coefficients are negative 1 and 7, so we do negative 1 times 7, which is negative 7. All right, and next we can look at our x's. We have x to the fourth times x to the fourth. So when we're multiplying, remember that we can add those exponents together. So in total, we would have x to the 8th. Okay, and then we have y to the first power times y to the 5th power. So again, remember we need to add those exponents, so that's y to the 6th power. It's important that we wrote that 1 in on the first y so we don't forget that there's one y there. Okay, and then we have a z cubed, or z to the 3rd power, and there's no other z's to multiply it with, so we still just have z to the 3rd power. That's our answer.
Oh dear.
Sorry.
Sorry about that. Okay, so in our second one, we clearly have a couple more steps here to do, but remember that the fraction bar means division. So we want to go through and look at our numerator and see if we can simplify that piece first, and then go through and think about the division of the numerator and the denominator. So again, we look at our coefficients. They both have a whole number listed there, and we look at our exponents, and we have two variables that we need to go through and make sure that we remember have an exponent of 1. So on our numerator, I'll write here next to it, our numerator, we have our coefficients. 4 times 2 gives us 8. And then we can go through each of our different variables. So we have x to the 2nd power and x to the 1st power. Add those exponents because we're multiplying. We get x to the 3rd power. Y to the 3rd power and y to the 1st. Again, we add the exponents because we're multiplying. X to the 4th power. And then our z's finally to the 4th and to the 2nd give us to the 6th power. And we'll put in that denominator again. My lines are going a bit crooked. And Miss Conley, what should we do now?
Okay, so now we're ready to take care of the division. Okay, so we can look at our coefficients, and we have 8 over 6. Well, 6 doesn't go into 8, so that's not going to be a whole number, but it is a fraction that we can reduce. So we have to look for the highest common factor of 8 and 6, which is 2. So we can divide each of those coefficients by 2.
Oh dear.
So she's writing divided by 2 there. So 8 divided by 2 gives us 4, and 6 divided by 2 is 3. So we've now reduced that fraction. Okay, so if we look at our x's, we have x cubed over x squared, or x cubed divided by x squared. Remember, when we're dividing, the shortcut is to subtract the exponents, so we have x to the 1st power.
Do we need to write that 1 in there, Miss Conley?
No, we don't, because it's implied, so we don't need to write it. And how did we know it was in the numerator, not in the denominator?
Well, we know that since we had 3 x's that were on the top and 2 x's that were on the bottom, we're really thinking about where we have that greater exponent, because those values that are being reduced with each other is leaving behind that 1x in our numerator. So since the greater exponent was in the numerator, then our leftover values is also going to be in the numerator.
Okay, so if we look at the y's, we have a y to the 4th in the numerator and a y to the 6th in the denominator. So in this case, there's more y's in the denominator. So they're going to end up, the leftover y's are going to also be in the denominator. And 6 minus 4 is 2. So we're left with y squared in the denominator. How about those z's?
Well, and since we have the same value in the numerator and the denominator, they're all going to cancel out or reduce with each other and give us a value of 1, which we then wouldn't have to put down. So I have to put those back in. We had an x and a y to the 2nd here. Okay, there we go. And then that fraction there is our final answer.
Okay, so the z's just canceled out because they had the same exponent. Now remember, if you forget the shortcuts, the first shortcut we talked about was when you multiply, you add the exponents, and when you divide, you subtract the exponents was the second one. If you forget the shortcuts, you can always just write it out the long way, like over there in red, what Miss Andrews wrote there, and then you cancel them and see where the variables are left.